Hello world, this is CS50 Explained Week 1. My name is David Malin and we're here with CS50's own Dan Armendariz.
Hey everyone.
Let's roll film.
So this is CS50 and this was CS50's own Colton Ogden. For more whose music you can download at soundcloud.com.
Yes, grammar.
CS50. So today we focus all
So in retrospect, I went a little casual this second week of class.
Wait, did you really take CS50?
I did take CS50 in
How did you-
1996.
How did you take it if you teach it?
Well, at one point I was a student here at Harvard College. I was actually a sophomore majoring or concentrating in government, and I finally got up the nerve actually to venture into a class called CS50. Even then I only got up the nerve to do so honestly by taking it pass-fail. The professor kindly allowed me to register pass-fail, which means I don't get a letter grade. I instead just get pass or fail.
You talked about that last time.
It gave me more comfort going into it, yeah.
You kind of talked a little too long for this joke to still be effective, but I was going to ask, Harvard has been around that long for you to be a student?
Yeah, since like 1636.
Falls flat.
Yeah.
That's where you
Oh, was
killed it.
that was it.
That was the joke. but-
This is the joke now.
No, this is the joke. not Mark Zuckerberg in particular. Just the
Wow.
video. Yeah. Oh god, that was
Wow.
bad timing.
So here we're borrowing a video from our friends at code.org, wherein Mark actually introduces a construct from computer science, or from programming specifically. And the goal here was really to just make something familiar with a familiar face.
Did we see an earlier code.org video last week? Am I remembering that correctly? Was that a different video that we saw last week?
Of Mark Zuckerberg? I don't think we saw a video of Mark Zuckerberg last week.
All right.
I don't know what lecture you were
Was it
attending.
code.org?
Code.org has a lot of footage, yeah. That was more of the montage of various tech figures talking about the value of computer science.
So this
and
was
programming.
actually talking about code.
Yeah, indeed.
Gotcha. So what was that language that just popped
Do you
up?
want us to make a video of you watching the video of the video? Then we could refresh.
Me watching Yo Dog.
So the goal here in week 1 is we need to bridge the world of Scratch at the tail end of week 0 to week 1, where we want to transition to something lower level but a little more traditional, namely C. And as you'll see here, I'm trying to remind students of some of the constructs we saw last week that are hopefully pretty familiar ideas, and slowly transition to C by essentially showing them the equivalent C code that corresponds to hopefully now familiar puzzle pieces. And here too, I like to keep in mind that most of the students in the class have no prior experience, so even though this is by nature review vis-a-vis the last week, and hopefully most of the students have started on their first problem set, which involves building most anything of interest to them using Scratch, want to make sure that we have everyone back on the same page. Few days have passed here, they've been shopping a whole bunch of other classes, and it would certainly be a shame to lose students on the 3rd day of class here, so we're doing a bit of review, make sure everyone's starting strong and on the right page. Here we have another video from our friends at code.org.
People make decisions every day. For example, before you go outside, you kind of have an if statement that says, if it's raining, then I need to get my jacket. And computers are amazing.
A little simplistic. But the goal really here was to involve someone like Bill Gates and Cameron and draw students in right away.
Well, I was laughing just because of the little rain cloud and the
That's hard to express in code.
overzealous, rain jacket. It's kind of funny if thinking back to the PB&J lecture, where if you were to just have that very simple if statement, what sort of results would actually happen if we were taking it very literally?
It's true.
If storm cloud, then rain jacket.
From the Albuquerque, New Mexico
Albuquerque.
Museum of Natural History and Science, where some of Bill Gates's and Paul Allen's
Is this, so it is, what, here is, this is what exactly?
So you'll see, this is an opportunity really just to draw in a couple of student volunteers. Now, keep in mind,
So I see some music stands, are they gonna
they're going to read.
they're
I have
gonna
a couple
read.
of
Oh,
printed
they're not gonna
scripts to have a
have a
couple of
little
students play this
duet
role.
of some kind?
Now, mind you, I may have created a little problem here by giving away some Philips Hue light bulbs the first week with the API for final projects, but that's not a sustainable giveaway week to week.
So tell me, what are these students going to?
Well, we'll see. Let's keep an eye out here. And the goal here, too, I could certainly just read the script that they're about to read, but the goal is to engage students here and to actually put on stage a couple of their classmates, male and female in this case, so that they hopefully have someone with whom they can approximately identify, or at least be glad that they're not sitting in front of some 700 plus classmates at that point to take the pressure off of it. Well, no, I mean, it works both ways. Either you sort of really want to be there, or you're sort of glad that you're not. And either way, hopefully it takes a bit of the emphasis off of me and my voice and puts it into the students' own hands. And here, too, these students were not chosen in advance. It was just based on the hands in the audience, so we never know how this is going to go. Fortunately, it's pretty low risk when you ask someone to simply read the following.
I think we kind of know how it's going to go.
Boop, 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 boop. Fast forward through any awkwardness.
How many people are going to recognize that tone anymore? So what is the story exactly?
Let myself explain.
Ah.
And what I thought I'd do in the overhead is accompany your recitation of the script
With the sing-along?
with some visual images.
Oh, visual images.
What I've done in advance is pre-highlight on your script.
So to make the story more
Just a
interesting
little-
than just text. This is a very forced exercise.
Yeah.
But we're workshopping a new idea. I'm thinking of using this in CS50 2015.
Really?
Oh, I tried it out in CS50 2014.
Yeah, but does that mean, wait, so you okay.
I test the ideas in the class itself.
Yeah, just whatever you like. That was not from this past winter.
No, that was from Google Images.
This past winter would have been a bit more snow.
No, I'm really just trying to tell the tale here of this script, and I Googled around for appropriate imageries so as to spruce it up in a way that's a little more visually engaging.
The two had already gone through a number of business ventures together, beginning at Lakeside School in Seattle, where they were paid in free computer time to test a PDP-10 computer at a local time-sharing company. The most recent plan had been to quit school and form a software company.
The hardest part here was keeping sync with the images, because you gotta,
You actually had to pay attention.
well, to the whole script and make sure I don't miss my cue. That was my role here.
January 1975 issue of Popular.
But these are the kinds of things, honestly, that we try out on different years. Like, I'm not sure I would do this particular one again, because it's kind of hit or miss. You don't know what to expect. But the reality is, even if we had beta tested this with a couple of the teaching fellows and myself, for instance, in the office beforehand, it's hard to tell until you actually take it out on the road, so to speak, and try it with current students, whether in a class as big as CS50 or something smaller. But I don't think that's a bad thing, because I don't think we would stumble on interesting demonstrations and good ideas if we didn't try a few others.
There was a mini computer kit on the cover of Popular Electronics.
But what you do in cases like this is you yield control, right? Like, for instance, if I were reading the script, I would actually be reading it a little more rapidly and trying to get us through it and trying to get a little more energy, honestly, in the reading. But again, chosen at random, so there was no seeding of thoughts here, and so didn't quite know what we would get, and sometimes works out amazingly, and sometimes we just relate the tale in a more matter-of-fact way, which is what happened here, and that's fine.
Well, the idea of conceding the stage, so to speak, works well in the context of a lecture, but maybe in a classroom situation, is that quite so necessary? Or to what degree do you think doing things like this in a classroom would actually be
I think
beneficial?
I don't know, it depends. It depends. I have many memories of like high school English class where we would read a text together as a class and sort of rotate who's reading it. And the goal presumably was to engage students or get them to kind of look forward to or just get better at speaking in that case. But I think it also helps take the emphasis off the teacher, right? Like at this point, we're already a week into the class, and I do want the focus to be on CS50 and on the class and not for it to be a 50+ minute monologue on my part. So anything we can do to kind of vary the dialogue and vary the participation and truly the camera's focus, I think is a good thing.
Out in Albuquerque.
And so I think you'll find a lot of the examples we do in class that involve many of the students is also intended to do exactly that, to sort of get people to like adjust themselves in their chair and kind of lean in and engage with the class as opposed to just listening to, again, someone like me drone on. So this was a new idea, and I think I might chop it down, or try something new altogether next year. Some of the demonstrations that have done very well, I think, is when we do have students come up on stage and pretend to be binary numbers, or in a few weeks' time, we'll have students sort themselves on stage, or represent a linked list with their hands as
Spoiler
pointers.
alert, come on.
True, sorry.
But what if the emulator was wrong?
As the plane approached Albuquerque, Alan realized that they're basic, now neatly contained.
It's funny too, because as I was reading through the script, I love the story here that's being told, and I read faster in my mind's eye than I think I would verbally. And so I think in retrospect too, these are the kinds of things I could have approximately tested out in advance. Like actually read the script aloud, time it, see how long it goes, and I think I might have tweaked something as a result of just beta testing with my own voice.
Expecting a clean little high-tech company run by men in business suits. So he was surprised when Roberts met him at the airport looking like a ranch hand.
But essentially what we're doing is, couldn't find a video on point to kind of tell this tale in a visually engaging and audio way. So we're replicating it ourselves with more of a sequence of slides.
Wasn't there a movie
MITS
that
itself was
you
located
used to show in class? Or was that Pirates of Silicon Valley?
We did.
Isn't that essentially this?
It's like 2 hours long though, so I
dramatic?
wanted a
Well,
5-minute
that would
version.
certainly take the focus away from the class, wouldn't it?
Just hit play, pass out some popcorn, and
Sounds
how it
awfully
goes.
familiar to what's happening right now.
The teletype began chugging as it pulled the paper tape through the tape reader. It took perhaps 15 minutes to load the program, then the teletype abruptly printed a memory prompt, then a ready prompt, and then Alan began typing a few tests.
I do think introducing a bit of the older technology that either I grew up with or preceded me is a good thing, so that students are at least generally familiar with the trajectory of technology, certainly from the PC era on up.
Alan on the arm. But at that point,
Especially,
No, there's multiple pages to this.
now had its basics.
yeah, the page turn is never good, especially when anyone's giving a speech and they turn the page and you're just hoping that that's it for the pages, and then there's a third, and
Yeah, yeah.
Thanks to our 2 readers.
Did you just cut them off? You're like,
no, that
more?
was it. That's the end of the script, and that's
Oh.
also one of Microsoft's earlier logos.
Oh, yeah, yeah.
Before you leave,
It looks.
Now here you're about to see 2 very disappointed students.
sparkly and a glow-in-the-dark elephant from CS50's own Gone.
And there's me tripping. So yeah, that was a very eloquent ending. No Hue light bulbs that day. You can, at this perspective, see how many laptops are open though in the class.
How many people are looking at Facebook at this particular moment?
It's unclear, but could be non-zero.
Faces from this actual theater. And now today, if you've not been, this is Maxwell.
So here what we're trying to do, and we've been doing this more in CS50, so as to vary the content and draw in related material that isn't conducive to just lecturing deliberately. We have some of the source code from one of some of the original work that Paul Allen and Bill Gates did and others. And this actually hangs in Maxwell Dork in the computer science building here on campus. And so this is actually one of these things where, like, I walked past this source code for years and never really thought about it or looked closely at it. In fact, CS50's own Glenn Holloway is listed as the user who printed out this source code some years ago.
Really?
So we sat down ultimately with Professor Harry Lewis, who's been a computer science professor here, went to school here as well, and knew many of the cast of characters involved. And he very graciously walked us through a bit of the source code and told us a bit of the history. And there too, I think there's this visually interesting element. And increasingly in CS50, I've been trying to have more of a multimedia experience, if you will, for students. So it's not just me lecturing, but it's me sort of choreographing or tossing between different segments, some of which are pre-produced, some of which are produced in real time by having volunteers up on stage, some of which are somewhat off the cuff, or traditional lecture style.
Sounds an awful lot like the big thing in the 90s. Everyone would get their CD-ROMs with their multimedia Encarta or whatever. And
I'd like to
super
think
excited
we're
about
very
it.
different from that. I think multimedia does not have to be a pejorative term.
Sit down with Professor Harry Lewis in the computer science department, who actually taught Bill Gates.
No, in fact, multimedia, it's an overused term, but like it does characterize what we've increasingly been doing in CS50, especially with the problem sets. So for many years, they were just PDFs of documents I'd written up in Microsoft Word, but more recently we migrated to the, frankly, obvious HTML format, in addition to PDFs for folks who still want to print. But what we've done is embed into them not only hyperlinks and a table of contents and just pragmatically useful things, but even Zamila's walkthroughs now are embedded much more seamlessly, I would say, into the problem sets. And this is because CS50's production team and Zamila shoots these walkthroughs against a white backdrop, very much like an Apple TV commercial. But the result, and this is super simple, is that the rectangle that defines her video just blends in seamlessly to what otherwise is the white backdrop of the problem set spec. And so it really is this sort of living and breathing document personified by Zamila. And there's just something about it that I think is much more engaging than a more traditional static document. So multimedia doesn't have to be sort of it really kind of defines that experience. Multimedia rich right now, I would say.
So here's an interesting comment up here. It says,
How many times do you see in those documents, or how many students sort of mention that they
so what that means is that
perhaps were able to understand some of the material better that was just purely text-based as opposed to being talked to with the videos and vice versa?
That's a good question. We've
And
never
how do you
run a
decide
controlled
where the-
experiment
How do you decide where the line is
between I
between
see.
text-based and video?
So we didn't do a good job at this at first. In fact, a lot of our shorts are just talking heads, humans, the teaching fellows and myself, teaching some topic on camera, white backdrop, but mostly just talking with a minority time spent on visuals or live demonstration of something. And that I think was a mistake because it really does invite the question, well, why not just type that up? And indeed we should have. So I think we've gotten better more recently about using text when it makes sense and using video when it makes sense. And I think the problem sets are a pretty good incarnation of this, where I write the text and Zamila creates the videos, and we marry the two together in a way that hopefully has high returns for Zamila's screen time, where she's actually doing something with sample code or with slides or with pictures or with interactive demonstrations of software that I can't do nearly as effectively with pure text alone.
How many times how often do you update the problem set? So from 1 year to the next, how similar are they?
Pretty similar. The reality is each one represents 40, 50, 60 hours of work in total, and each year we find...
On your part?
On my part. We find imperfections, we make improvements, fix things that are unclear, or just the problem set numbers get changed around and we decide to add different test cases to it, or just make certain tweaks based on students' feedback and based on confusion that we realize, oh, we could really head off this confusion by answering this FAQ in the specification itself. So every year they're marginally different. And I aspire to change significantly, maybe 2 of them. I'm actually pretty happy with where most of the problem sets are at. PSET 0 I think works well for Scratch. PSET 1 I've never loved. I feel like we can do a better job, but it's hard to get a super interesting problem set out the door with that very first week of C code, because there's only so much you can do, and C does not certainly lend itself to the most dynamic of programs when you only have loops and conditions and variables at your disposal and not much more else of a mental model. Let alone GUI.
How long does it typically take for what is the average amount of time that a student spends on a problem set?
About 12 hours outside of class, but super high variance. I would say fastest students with significant prior experience might finish a PSET in 4 hours, maybe 6 or so, so very few. But 12 is certainly common. 15, 20, 25, we get reports of 30, 35 hours, for which hopefully there's an adequate support structure in place, especially for those students. And sometimes it's because they're really struggling, and we do need to swoop in with that support structure. And other times it's just because we need to try to help them strategize better and work through the problem set a little more smartly. Learn to use a debugger, or even just learn to use printf to figure out where your problems are instead of just banging on the code and resorting to trial and error. So a lot of variance, which is indicative of, think of the spectrum of the class.
And how long do they have to work on one of them?
About a week at the college here. So they go out the door on a Thursday or Friday, and they have till the next Thursday or Friday. So here, this is a simple manifestation of, I think, some of the highest returns of Scratch for us, beyond the excitement that hopefully students get in that first week of class of building something that's engaging and interactive, that they can show their family and friends. It also allows us to introduce concepts like conditions and loops and statements and any number of other concepts that Scratch supports, even threads and events, and then translate them so readily to C by having these very simple examples of here's the Scratch code, here's the corresponding C code, and my hope here is that even if that bottom C code looks cryptic, like what is int, what is void, why the curly braces, how do I even type a curly brace, why is there a semicolon at the end, if you just take a breath and appreciate, okay, and take on faith for now, okay, that is functionally equivalent to the thing on top. My hope is that that is a hugely reassuring message, that if you understand the puzzle pieces, the rest will come in due time with practice and exposure. And that really is the goal here, to send this very emphatic message that in this week 1, first lecture, first exposure to C, there's really no new ideas. It's just a different incarnation of the same ideas, different syntax. Here again, and I deliberately am kind of flying through a couple of these just to send this message, like no big deal. And even if you couldn't reproduce that code after closing your eyes and retyping it, not a problem, so long as you understand what it means to do something forever, which is hopefully very accessible.
Trying to show how to read it at least initially.
Yeah, reading code and just beginning to notice patterns, right? I see a couple more curly braces. I see a couple pairs of parentheses. I see that semicolon again. Don't know what it means yet, but presumably we'll get there, and indeed we will. And notice too that I'm not teasing apart all of the syntax here, or the semantics. Like true, why is there the space there? While, what does that mean? And I'm trying to give a visual, like while. Okay, I understand the semantics of while in the English language, so presumably is involving something cyclical, but we'll come back to that. And now I'm finally saying, all right, while true. So if true is not a variable, it's just a statement, it's always true, so while something is true, just keep doing it.
Does this not sort of bring up the question of why is there this seems sort of roundabout way of saying forever.
Roundabout way.
Yeah.
It is, absolutely.
So do you ever get any questions of why is there not actually a forever word?
All these years, no one has ever asked. And I think that's a perfectly reasonable question. I think most computer scientists would argue that, well, this is the way these languages tend to start out, and it's meant to be a generalization, so that it's while a condition is true, and true just happens to be the simplest such incarnation of a condition, or true or false. But frankly, I would like, you got to think that some non-zero number of students have thought that now, and I think that it's a very good question. No reason you couldn't make your own language that has that, but as we'll see is going to be the case. We're going to build features on top of other features, and so long as we have a way of expressing ourselves, we arguably don't need many, many different ways of saying the exact same thing. Indeed, a programming language is arguably much less expressive than a spoken language. So this example I regret. So here,
Well, we saw this last week, didn't we?
right. So this was the glass bowl represented a variable or storage container, and the ping pong balls represented values. But as you noted last time, because I was using a different number of ping pong balls and not a fixed number of bits, I think it was sending a confusing message. So we won't use that again. So here I want to introduce the idea of a variable. And notice this time I'm focusing on the Scratch code first, because there's more puzzle pieces to absorb here. I want to make sure everyone's on the same page that, okay, got it, this is just a loop that's incrementing a counter. And then I'm going to reveal the C code so that their eyes are guided, hopefully from left to right. And even though, again, I probably couldn't reproduce this for you, at least not without some practice or looking back and forth. Okay, I see the while again, I see int, so maybe integer, counter. The equal sign's a little weird because that usually means equality. We now have to coax students to understand that it means assignment from right to left, but we'll get there too in time. The goal is to really take out the fear factor in this first week. We're not trying to teach them how to write C code yet, just how to identify it.
So I think one of the big elephants in the room, perhaps, for those that are considering using the CS50 curriculum is, in fact, the decision to use C, which was actually, so when I was in high school, the AP computer science class was in C++. And then after that, they moved to Java, higher level language. So what is the rationale for using C in this case? It almost seems like a regression.
Well, that's a loaded question now. So these things, of course, as you know, very quickly can devolve into religious debates. So I always concede from the get-go when asked this very frequently asked question. I'm sure we could teach a similar or equivalent version of CS50 with most any language. But the reality is C is a very small language, which means we can introduce students to almost all of it. In fact, the only thing omitted is really function pointers and unions as features of the language. And we can have these very low-level conversations that allow us to talk truly about what's going on underneath the hood without the abstractions that higher-level languages afford, like Java and its references as opposed to actual pointers. So we can actually talk about what is underneath the hood of your computer. What is your RAM? Well, you can think of it as just as a big rectangle, each of whose blocks is addressable as a byte. And indeed, when you are calling a function, you're given a few of those bytes. When it calls a function, a few more, a few more. We can actually see in a picture where those variables on your so-called stack are being stored. We can talk about even the most sophisticated of attacks, like a buffer overflow attack, and give students mid-semester into their very first computer science course an appreciation for what this attack is that you still, to this day, hear about in the context of servers or software being exploited. And those are conversations that you just couldn't have nearly as readily with a higher level language. Now, with that said, we pay a price. It's a lot harder to do exciting, interesting, cool problem sets early on with C because you're pretty limited in terms of the library support, in terms of the GUI support. But even then, Eric Roberts, the Stanford Portable library that we use for Breakout right now, allows us to pretty quickly get back into a very visually interesting environment from scratch now to Breakout. And so that's helped bridge that gap. But for me, what I like is that we're not trying to graduate computer programmers from the class. We want them to be computer scientists, or at least have that foundation and that confidence to be able to have a discussion and an understanding, ground floor on up, what's going on. And it's a very powerful thing, honestly, I think, when we context switch later in the semester from C to PHP in our case, and we take what took dozens of lines of code in the misspellings piece set to implement a hash table or try and distill it into like 1 or 2 or 3 lines of PHP code, but then we show students the performance hit you take when implementing the spell checker in PHP as opposed to C, and you very personally appreciate just how much layering and abstraction there is. Not about time wasted, though we deliberately tell them about PHP after that piece set is due. And I think that's powerful because you really appreciate what's going on. And I'm sure you could teach that in another language at a higher level, but I really feel philosophically that the trajectory works well, even though the other price we pay, arguably, is the difficulty with which students approach pointers. Even for me in learning C years ago, by far the toughest concept to wrap my mind around. But once you do, you understand how a computer works. And from there, it's all onward and upward, I think.
And do any of the problem sets sort of focus on these key things? So you mentioned that C is a very small language and that they might be able to learn most of it. Doesn't sound like we actually go over all of it in CS50, but at least most of it. And does that actually provide like a tangible, do you think the students actually have like a tangible appreciation for that coming out of the class?
A tangible appreciation for?
Knowing what we are describing as the bulk of the language, the bulk of the C language. So in other words, can they look at an arbitrary C program and kind of get an understanding of what it is that it is doing?
Short answer, yes. I would think for many, if not most students, I would absolutely hope that that is one of the takeaways for them, this ability to recode. With that said, because they tend to see the same style of code all the time, I wouldn't be surprised if some students struggle to pick up on someone else's indentation technique or where the curly braces are going, and that might give them pause for a moment, so it's not a quick read from top to bottom. But we show in some years so the source code for a jailbreak exploit for the iPhone from back from 2007 when it first came out, and jailbreaking means hacking your phone to install third-party software on it. And that code is written in C, and even though there's some syntax that's a little unfamiliar, you can very quickly recognize the while loops and for loops and variables and function calls and main, and I think that's powerful, even though they don't need to understand something like that specifically, just to realize like, oh, I can do this. It's just like Scratch. It's all these little building blocks on top of which you're building something more interesting. So here what we're doing is introducing the so-called CS50 Appliance, which is, of course, a virtual machine, happens to be running Ubuntu, but really it's running one operating system in a window on your own Mac or your PC. And what we're introducing this for is so that every student has a standard environment. They don't have to wrestle, hopefully, with stupid technical difficulties of like installing their own compiler and their own debugger and a number of other tools on their own native operating system and different versions of that operating system, no less. It's not without its pitfalls. Getting a hypervisor, something like VMware or VirtualBox or any number of other products to work is sometimes a challenge, even with things like networking drivers, but on the whole, hands down, this has been prerequisite for success of students online, especially to have access to precisely the same environment that for many years was a server cluster on campus that is now distributed across all of CS50 students' own laptops and desktops.
Does it replicate a realistic environment for students?
It does. I certainly hope so. In fact, we have configured the CS50 appliance to be very representative of a commercial web host, complete with tools like PHP and Python and Ruby and Node.js pre-installed, PHP MyAdmin and MySQL and other tools that they might encounter or want to use for their final projects. So there are relatively few tweaks we make that are CS50 specific, other than the menu that's glaring in our faces right here.
And the background that says
But beyond those aesthetic customizations, this is a pretty representative environment. And in fact, a lot of the course's staff, myself included, use our own CS50 appliance, not so much for course purposes, but for our own software development purposes, because it's a pretty representative and a pretty cleanly configured Linux server. So here we're using GEdit. When over the years we've used different text editors. We used Nano for some time, past years Vim and Emacs, both of which I think are too much of a nuisance for students, especially less comfortable, to bother having to master. And so we introduced not just Nano, which has at least syntax highlighting, but a fairly simple text-based interface. We introduced GEdit a few years ago, which has been a win, because it's not a full-fledged IDE or integrated development environment, but it does offer syntax highlighting. It numbers the lines for you, helps with indentation, so it gives you a little bit of a support structure, but still leaves the essence of the work to students. But it has a terminal window embedded, which is just convenient, so students don't have to necessarily wrap their mind around like lots of different programs running. They can stay pretty much in this environment, at least till some of the later P sets.
It's kind of interesting that we were just talking about how you use C to really allow them to have an understanding of what's going on under the hood. And a lot of the problem sets are based on using the command line interface and teaches them how to do that. And yet here we have a GUI-based text editor, and I appreciate that, the idea that for less comfortable students especially, that they would want to have something that's a little bit more familiar. Do you transition at all towards the end of the semester towards using an editor that is not GUI-based and really allowing them to kind of manipulate everything under the hood?
It's a good question. Short answer, we don't. We sometimes, some years have seminars or optional tutorials led by the TFs on tools like Vim and Emacs or your favorite text editor, I mean, Sublime Text, which is GUI these days, but very much in vogue. Short answer, no, mostly because I do feel like the students are doing the most interesting work at the command line, the compilation of code, the looking at the debugging messages. And what it really was for us when transitioning from Nano to GEdit, just so many students were understandably in the habit of like being able to click or move the cursor. And like there's frankly an efficiency to be able to clicking or use clicking and just going right where you want, or highlighting and cutting. And the fact that we were limiting their capability to do some very reasonable and very familiar tasks just felt like a net negative. And so GEdit allowed us to assuage those concerns without throwing too much hand-holding at the students. I mean, it's essentially text edit for Mac OS or Notepad for Windows with just a couple more code-friendly features. So I think it works well, to be honest. And we've tried pretty much every possible text editor and IDE and have been very happy overall with GEdit. And here we're trying to help students understand how you build the code. You go from your source code to your object code or your executable code, and we very deliberately use make in the beginning. We don't have them type clang on their own, because make, frankly, is wonderfully named because it sort of does what it says. We do show them underneath the hood the command that it's running, and in fact it's fairly cryptic because we have a number of flags pre-configured in the appliance that essentially make error messages a little more instructive and sort of forces the students to correct certain deficiencies, and it also links in certain flags like LCS50 and LM, and sometimes LCrypt rather, for one of the hacker editions of a problem set. But the goal here too is we want them to understand the compilation process, but we don't want the details to get in the way. Like I don't want them to have to remember on the very first day of learning C to include -LM or -LCS50. We want them to understand those eventually, so we'll take the training wheels off, but we want those training wheels in the first day. And this is what I think IDEs do a disservice to. Like I've encountered too many students online or even coming out of high school who have only used Eclipse or Visual Studio or NetBeans or any number of other IDEs, and as soon as they see some other environment, they don't even necessarily have a mental model for what they want to do or how to configure it or how to customize it with the right linker flags or how to pull in some other library because they've always had that GUI. And so I do like that in CS50, much like using C from the ground up, we're similarly using a command line environment from the ground up and then gradually introducing more sophisticated tools.
If you don't tell the computer to move that blinking cursor to the next line, it's not going to do it. So when I run the
And here too, we're sending maybe the second emphasis, my second emphasis on the importance of telling a computer exactly what you mean. It's not sufficient just to indent, it's not sufficient to write in pseudocode, you have to be super precise. And so here I've deliberately made, it's not always deliberate, but I've deliberately made the mistake of omitting the new line so that you see hello, comma, world J Harvard, where the output of the program is running into the prompt of the shell. But that was deliberate because now, okay, what's the issue here? You have to somehow tell the computer, insert that new line, so the problem to be solved is very well defined, and there's the solution. It might look cryptic, But at least now students hopefully have that visual, like, oh, wait a minute, we saw this in class, what was the solution? Like, that's the memory we're trying to trigger. Rather than talk about it, we want to show it. And here too, I'm showing what might be people's natural instinct. We'll just hit enter, like a Word document or an essay that I might write. But it's not going to like something like that typically.
When you want to put the cursor onto a new line explicitly, you must explicitly say new line.
And I would argue too, even though we're starting to venture into the arcane, we've offered a definition of the problem, we showed the problem, we've proposed what the solution is, we've argued in favor of why this makes sense. You have to tell the computer explicitly what to do in a clean one-line way. And hopefully now students can be nodding their heads like, okay, we got that. Never knew that before, but now I understand.
Into my Dropbox folder. As you'll see in the CS50 documentation for the appliance later this week.
So it seems like you tend to do a lot of live coding. Is there kind of like an appropriate balance between the risk of something going wrong and maybe
Yeah.
also kind of how perhaps uninteresting it is to just watch you type?
I'm just so fast. Look at me go.
Well, I
That
don't
was
know if I'd call that
magical.
fast. Was it?
No, it was.
Six,
It was.
6 lines and
No, there we go. It's a good question. Generally, when starting a conversation, I'll try to live code as much as I can, especially when the programs are short and I know I can type it pretty fast and with high probability, few mistakes. Though frankly, all the better if I do occasionally screw up, because that's an opportunity for one of those teachable moments where hopefully the audience will notice it. Hopefully I'll notice it too, and we can correct it together. But all the better, honestly, if students can sort of fall back on this recollection of like, when they struggle with some error, they're not quite seeing it, all the better, frankly, if I've kind of led the way by embarrassing myself, by struggling to find some bugs so that they realize it's okay. And they're just like me, they're just like any programmer, certainly one who's learning for the first time. But what's key here too is like these are very deliberately small programs. They're indeed being live coded, and that's mostly so that there really is no magic here. Like everything that's happening is the direct result of my having just created this. So to answer your question earlier about when we start to draw upon like pre-written code, sort of the Julia Child style of taking something out of the oven that's pre-baked, I sort of...
Did I ask that earlier?
What's that?
Did I ask that earlier?
You did.
Oh,
Yeah.
that's good.
Right?
I don't know.
Rewind to confirm, but yes, you did.
TiVo.
So you kind of know it, right? Like if I start to feel like this is starting to drag, or like kind of people are kind of shuffling their papers or laptops and their seats, then you kind of know like, okay, it's time to pick it up. Let's take comfort in the fact that we have the walkthroughs of these same kinds of programs that we've pre-recorded online that students can look at.
Oh, the pre-recorded.
The walkthrough, so to speak, where I walk through literally every one of our 100 or so examples in C and other languages, but hopefully in a way that's instructive, maybe deliberately a little slow, but so that a student at his or her pace can work through it really on their terms and not on the terms of a live lecture. And notice here too, so like, again, all of this is unfamiliar to most students, even though it looks like Mac OS or Windows roughly. I'm trying to make sure I give a verbal definition of everything I'm doing. I don't just start clicking around like, you know, a tech support person might if they just take for granted that you know what they're doing. You got to explain every step so that the students, even if they've not seen it before, and maybe they might struggle to replicate it, they at least have been, you know, shown the respect of like being told what's going on so that they can follow.
How much do you think this virtual machine actually might alienate students from the idea, and at least take away a little bit of how real this work actually is? Because if they're not familiar with Linux, if it does look just subtly different, then they may get sort of a different impression of what it is that they're looking at. So taking, you know, granted that it's good to be able to standardize the environment for all of the students, it also does take a little bit of that away from them.
Early on, and this is, you know, self-defensive on our part because we know what the alternative is, and we and many other CS courses here at Harvard have certainly experimented with instructions of having students install this, configure that, do that, and it's just a net negative, just from too many semesters of experience. But I would argue too that on the one hand, what we're doing, yes, there's an operating system here, yes, it's Linux, yes, it is GEdit on top of that, yes, there's Clang. To many students, it may very well just be perceived that this is CS50 software. So this is a program I've downloaded to use for CS50. And indeed, there's a huge amount of complexity underneath the hood, but all students are familiar with having downloaded some new program for the first time that gives them newfound capabilities. And we're simply defining those capabilities. And by the end of the semester, for many students, these training wheels do start to come off because they sign up for a commercial web host and they put their code on someone else's environment. They get adventurous, install their own web server or database on their own Mac or PC, and they start to venture outside of the appliance. But even if they don't, it's very deliberately configured not to be some toy environment, but representative of most any Linux server or Linux workstation. So in that sense, I don't think long-term we do any disservice to students. If anything, I think we equip them with a pretty user-friendly programming environment that's easier to maintain, that's easier to update in isolation of their own system.
To what degree do you think it'd be useful for those, so for classes, high school class, for example, that wants to use this curriculum and perhaps they have access to a computer lab that are already all of the same type of computers with the same operating system. Is it still beneficial to have this sort of setup as opposed to
That's a good question.
creating or replicating an environment within that might remove that sort of abstraction away from?
If you control a computer lab, then you have an advantage that we don't, because we have so many more students, and just for logistical reasons, it's not ideal for them to use the computer lab. And the reality is, at least here in campus, most students do have laptops these days. And so that's an advantage, I think, if you have a standardized environment. And frankly, I would just install Linux or maybe Windows or Mac OS, but install all of the same tool chain. However, if following along with CS50's curriculum, one of the values of using the same environment is, of course, that all of our documentation, all of our videos, all of our examples, at least from the most recent year, will line up perfectly with your own environment. And so I just think there's non-trivial, just logistical value for everyone being on the same page. And I think if we were limiting ourselves to using a more restrictive tool, that might be a bad thing. But the sky is the limit with what we can do in this environment. And we've just deliberately tried to use some of the simplest tools, at least in week one.
So I saw what looked to be a little bit of magic here, where as you were walking away from the lectern, the mouse highlighted line 2. Is there someone?
No, this is just me, so I
behind the
think I did that very discreetly and then walked away.
Oh, interesting.
There's no one else
Very-
controlling the keyboard.
Very magic-y.
This is a great feature, honestly, of macOS that is not
Zoom
enabled
in.
by default. And actually, before this disappears, this is why we use Clang instead of GCC, a better known or longer compiler that's been around a long. Its error messages are better. They're color-coded like this. They do what they can, albeit in ASCII, to draw your attention to the offending line of code that seems to have some error. And that is why we switched to Clang. It's just been better pedagogically, but offers pretty much the same feature set. And indeed, the switches and flags are all the same. But the feature I was alluding to earlier is actually a Mac OS thing, not a CS50 Appliance or Linux thing, whereby if you go to your Apple menu system preferences and accessibility,
Right.
this is a zoom feature so that you can use your mouse or a keyboard shortcut like Command Option plus or minus and zoom in on the screen. And pedagogically, and other operating systems have their equivalent tricks, this is hugely advantageous. I've certainly sat in on far too many classes or talks where the instructor did not necessarily zoom in this way, and it's just too easy to lose the audience over something stupid like that. So these are the kinds
really
of things
helpful.
that are worth being mindful of. So just Googling, Mac OS zoom in on screen, Windows zoom in on screen. You can find either native solutions or third-party software for sure.
So now, having made 2 changes, we zoom in.
And here too, I mean, simple stuff too. Changing the resolution of your monitor to be like 720p instead of 1080p so that everything looks a little bigger and you have less real estate to work with, but it's better certainly for the students to see. But more important that they can follow along.
Now, if I do /hello-1, I should see hello David. Pretty underwhelming, though, right?
So I have this habit, and perhaps it's an insecurity of sorts. Anytime I'm very proud of myself for having taught a very simple program, like I sort of disclaim, like, okay, underwhelming, it's not all that great, but that's also to make sure that especially the more advanced students realize, like, we're going to quickly like move on to something that's more sophisticated, more challenging, but we don't want to be diminutive at the same time. And so I think everyone can sort of agree that a program that says Hello World is a little underwhelming. So it's not a pejorative, but really it's an acknowledgement that we're really just beginning and the good stuff is still on the horizon. But even so, it's pretty magical, I think. Even I can remember, writing a program for the first time and understanding the sort of concepts of what's supposed to happen when you run the command, and oh my God, when it actually works. That's pretty gratifying, no matter what the program does. That happens a lot, actually, with our forensics piece, where students have to recover a whole bunch of photos from a forensic image of a digital media card. And there's that moment when you suddenly recover 50 some odd photos from a memory card because you finally got your code just right, you ran the command, and boom, 50 JPEGs.
The all or nothing approach, where they either get gibberish or
Yeah. So there's some non-trivial downsides there too, but boy, does it feel good when you get it just right. So here we're using the so-called CS50 Library, which we inherited essentially from Eric Roberts, also from Stanford, the author behind the Stanford Portable Library that we also use. And it's partly for historical reasons that we capitalize the function names in this way, which is an FAQ for some, using capital G and also capital S, so not quite camel case. But it's not been a bad thing because it also, I think, sends a very subtle message that this is non-standard. And indeed, this is a training wheel that eventually we jettison altogether from the class. But it's a great opportunity to continually reinforce what the notion of linking is, why you have the sharp include at the top of the file for the declarations of the functions that are in there, because I think it's a very safe way for students to fail unintentionally at getting something right, because it's very easy to omit the -L CS50 if you don't use make, for which we pre-configure the flags, or if you accidentally leave out CS50.h.
Well, you got your lunchbox back.
Yeah, so now
Tupperware.
I'm using it as a black box that's see-through. Sometimes I realize in the middle of a class that it would have been good to bring a black box today. So it's funny, it's a simple thing, but like making notes to yourself, especially at the end of class, before you get distracted, before you get distracted, before you go off to lunch or start doing other things, I will very often like just write a super quick bulleted list of like, this worked, this didn't work, don't do this. And I try to remind myself, because I might not look at those notes for 364 days, and I want to make sure I don't repeat the same mistakes, and sometimes I do. But having notes actually has been a wonderful resource for the class we principally make for the students, and one of the TFs goes through the lecture and tries to distill it into its essence in note form, so they don't have to have their heads down, scribbling down everything I say. They can lift up and engage, hopefully, but trust that there's a resource ahead on the horizon for them. But the notes have been invaluable for me too, just pedagogically being able to look back on what we did, to rethink, was this the ideal order? And it's so much more powerful than just the raw transcript, which is thousands of words, and it's harder to wrap your mind around what the arc of that class was. So this was a deliberate bug.
Right.
One of few deliberate bugs, but trying to prod students to think about what's happening.
This is interesting because I think it gets to be, this code is simple enough that
Make hell, sorry. Sometimes it happens by accident, sometimes it seems funny at the time.
it just seems to be the risk of using the program hello.
Yeah.
Anyway, this seems to be one of the benefits of this style of live coding, is actually running into bugs that occur as you're actually working on it. And it almost seems as though like that scripted one was almost, there seems to be a benefit to when you actually make a legitimate mistake, and there's a moment when you have that face of confusion and you have no idea.
The look of panic?
Yeah, that moment I think is more beneficial for students than the moment of, oh, here I'm going to intentionally run it incorrectly.
So I should try harder to screw up.
Well,
Or pretend to have screwed up worse.
maybe be a better actor when you actually want to, when you script one of these teachable moments.
That could be interesting. I've tried to be in good faith consistent with what's actually going on in my mind. So if you see me hunch over looking at the screen, kind of wide-eyed, that usually means I have no idea what's going on and I am horrified.
Yep. Some other tells include oh, what do you think is happening?
Oh, that's a great stall technique.
Yeah,
Toss the
just
question out.
ask the question.
That's an interesting
That's an
idea.
interesting
Who
problem.
else might know what's going on here?
As you keep looking at the screen and have people think about it.
Yeah, it happens sometimes.
Oh, so what is this mess? What's going on here?
So this is an example of obfuscated C, where the goal is to write the most complex looking code you can and outdo your peers. I always honestly have misgivings at showing something like this because it is completely overwhelming by design, but it tends to have such cool effects, or it's just kind of, at least even for you can't quite hear it. Wait, there was an ooh and an ah there.
Yeah.
And frankly, this is kind of random, but there's only so much you can do with C graphically, and so it seems to get a wow. But I'm not sure I would dwell typically on the code, because I don't want students to even think that that's the direction we're skating in, like to write really cryptic bad code. But there's this cool factor, like, wow, look at what I can do. And speaking of wow, here's CS50's own Colton Ogden performing in the studio on his Novation Launchpad, which is sort of a modern piano, if you will, though I'm sure you would cringe if I were describing it as simply as that.
I think we saw this a little bit last week too. He played
Indeed,
different
bit of a
songs.
live performance, and then at the end. This was fun though. Like, this is admittedly well beyond the boundaries of a typical CS class.
An indulgence, maybe.
Okay.
Indulgence, rather.
I mean, I'd like to think that it engages students and gives them something visually interesting and audially interesting to engage in. I think, frankly, the fact that it is unusual in and of itself has non-zero engagement value. And it's just been kind of fun. And in fact, one of the goals at the start of the term was to do this on a semi-regular basis, like once a week or so, and then use some of the same tracks at the CS50 fair and maybe even the CS50 hackathon. So the course kind of had a soundtrack to it, so that you sort of have this emotional closure at the end where you're hearing some of those same songs from the earlier weeks. And indeed, we've done that. And in hackathons, we've held that since Colton's performed. And so it's kind of become a thing in a good way. But absolutely strange.
I remember when you used to have just playlists of music that you would
On an
play.
iPod.
Yeah. And you just
Then-
plug that in and
Then we
hit
moved to
play
the
and-
Spotify, or the iTunes, and
really?
then the Spotify.
Oh wow. The iTunes, the Spotify.
Well, I was on the Facebook before a lot of people too, so that's how I
Yeah.
got to use these
Dating
kinds of
yourself here a
tools.
little bit.
This is actually beautiful too, and the studio is even prettier than seeing it performed in Sanders, because the team got the lighting just right. We had this beautiful animation in the background there. The table
highest-
wasn't vibrating every time you hit it.
The highest quality camera.
This was shot with a higher quality camera than the one we had propped over the stage.
Understandably, we had a smaller camera, I think, that
On the stage,
on
yeah.
the stage
yeah.
from last week.
So this one can be done just right, and he can rehearse and shoot it as many times as he wants to feel happy with the outcome.
I remember this was
It's
a.
beautiful though, I think.
I remember this was a stylistic point, was that there's that one
I
button
know!
that's illuminated
I hate
just
it.
all the time. Yeah.
I took some black tape to it at one point, but then you could see the black
You could
tape.
see the black tape, right? Yeah.
So we never got around to this, but Ansel Duff, one of the undergrads who spent some time with us in an engineering capacity, used to chat with him about maybe forging a 3D printed object to
gosh.
cover, but we never got around to it. This is hard to perform something like this, I'm
I'm
sure.
sure, yeah. I remember Colton practicing quite a while to get this just right.
Yeah. Oh, this looks amazing.
It's neat because I think he was telling me that in the so this is actually connected via USB to a computer,
Yep.
and so as he plays, it's not the sounds that are embedded within this device, but instead it sends a signal to the computer saying
Yeah.
which button he's actually pressing, and it's the computer that replicates the sound. But further, the computer can then send signals back to create these different light shows as he's actually within different sequences of the song, which is pretty neat. So there's some that they just have wild, just like this, just wild sort of sequences of lights, which is kind of neat.
Yeah, there's some really sophisticated software underneath the hood, but the communication over the cable is really just as simple as sending the unique ID of the key.
Have any students tried to replicate this sort of thing for their final projects?
We've seen some musically themed ones. I definitely remember in a recent year, a student brought his own keyboard, for which he had a MIDI cable connected to his laptop as well. And it's a nice intersection, I think, of the arts, or music specifically, and computer science or programming. Colliding these worlds creates very interesting effects. Very beautiful effects. The lights, the sounds, the music, and then the human aspect.
Right.
This got deep fast, week one.
Oh, I know. It really did.
Thought we were talking about computer science before. But here we
Still are,
go.
right?